In lecture 9, we're going to learn some basic ideas about file system, paths, and also we'll introduce a very useful module called pandas for data analysis. In lecture 8, we learned how to create maps using the base map module, and which is pretty fun. And you can create all kinds of map projections, and you have already practiced that. And we also learned how to plot spatial data points on your maps, and we learned basic ideas about loading some files. And in this lecture, we will introduce concepts of file systems. And since you're going to start work with data files, and also we'll have introduction to pandas. And this is a much more powerful method for load data. All right, so when you try to load the data files using the NumPy function, if you still remember that, we use the load txt, or the other one is gen from txt, and you have all kinds of options. And then we load this, and when we do the index slicing to get each column and push them into one-dimensional arrays. And you know that this is the file name. And the question is, how do Python know where to find the file? And lots of them, you probably know, have already noticed that I told you that when you try to open your IPython notebook file, make sure this earthquake.csv file is in the same folder as your IPython notebook file. Same folder, sometimes we also call the same directory. So if you look at this, this is my IPython, my directory, and you can see that I was opening lecture 8.ipynb, and the earthquake.csv file is right here. It's at the CSV file. So when you're trying to load a function and you tell the load txt function the file name, and it knows that to look for this file name in the same folder as the ipynb file. All right, so this is my ipynb file. This is the earthquake.csv file. So the function knows how to find it, right? So they're in the same folder. So in other cases, you will see codes like this. So now in this case, I'm using the same function, but the function input is slightly different. So it's called datasets/earthquake.csv. What does that mean? So that means this is a file location plus the file name. So file name is still earthquake.csv, but location is changed. So now I've put the earthquake.csv file in a folder called dataset, which is at the same location as my ipynb file, right? So how do Python know where to find it? It's the same idea. So you can see that this is now my folder where the IP lecture 8 ipynb file is. Now I have a data folder called dataset here. And this is my file. And this is the folder where the data is. And you can see this is the earthquake.csv file. So by doing this, now the earthquake.csv file is not in the same location as this one, but it's in a folder called datasets. So Python, as long as you tell Python where to look for it, now it's going to look for this file in a folder called datasets in the same location as your ipynb file. So to summarize, so two types you can do it. One is that if you type in directly the name of the file, Python looks at the current directory to find the file. If it's not in the current directory, in Python, you need to tell Python where the file location is. So it's the location plus the file name to look for the file. All right, so specify the location and file name of file, which is relatively easy. So in the Mac system, I think PC might be slightly different, but in the Mac system, what I do here is that what I did there was I specify the folder and file name. So what happens here is that this is the location of the file name, and this is the name of the file, and these are the options. So if they're in the same location, and you don't need to tell the location explicitly, otherwise you need to tell Python where to look for it. All right, so now this comes back to an important idea about what's a file system and how do I look for, or how do I specify the locations. So for most of the codes, and you may not need to use this, but you need to get an idea of what it is. So the organization of computer is based on the file system. And the file system is layered in this case. And in the top, you'll find the root directory, and then you have system, library, users, and this is my username, and then under your users, you have desktop, pictures, music, documents, etc. So it's a very layered system, and as long as you know how to specify where that location is, and Python will know how to find it. Right? So these are the commands using either a Mac OS or Unix system, and some of you use PC and it's slightly different. And I have a table to show you how to use that later. All right, so when you have a file system and the way that you specify where the files are, that's called path, right? So the concept of path is to tell you where to look for those files. So the idea of a path, there are two ways to specify idea. One is called absolute path. So absolute path, you start from the root and you go to the next level and you go to the next level and you go to all the way down to where it is, right? For example, if I want the root and in a Mac system or Unix, and it's just slash, right? So if I want to go to this user file, it's slash users, and then Python knows that go to the root, highest level of the file system, and there's a folder called users, right? So now I go to the next one is lemmatangle here, right? So I go to here, and then I find a next level. And then if I want to go to desktop and then go slash desktop, so this tells Python to look for this folder exactly where it is. So starting from the root all the way to the lowest level. So that's called absolute path. It's like your home address, right? So your home address is Tower 7, floor 5, apartment A, Cherry Road, and Poplar Road, all these all the way to the level everywhere. So there's another way that you can do is called relative path. So relative path is just like tell Python. So starting from the current directory. So either it's on my left or on my right or on top of me or below me. So this is like you're telling Python where your neighbor is, right? So relative paths are handy. Basically, they're shortcuts. And then the syntax here goes like if a dot slash means it's the current directory, or you don't do anything. If you don't specify path, it's the default says that's the current directory. And double dot slash, it's one low level above. And two double dot slash, that's two levels above that, and so on and so forth, right? So these are two ways that you need to know that there's absolute paths and there's relative paths, and you can use these to specify your location of your file together with your file name, so Python know where to look for it. Right. So this is a Windows system file path. You can see that. So this is what I find because I haven't used Windows for many years. So this is about the best I can find. So you can see that. So if you look at environment variables or right click something, and you can see path here, a variable called path, and then this is C, slash and program files and all these, and these are absolute Windows paths. So from this, so if you want to put your file in some location that is not the same location as your homework file or practice file, you need to specify path. But if you just put all the data files that you're going to use in the same folder as the practice or homework files, and you don't need a path, right? So it's you need to learn all these through practice, but this is not required because this is we're not gonna spend too much time on that. But that's an important concept you need to know. So in the Jupyter Notebook, there are a couple of useful command lines, commands, and we call Unix or Mac commands. Then you can type in your code cell to do things such as listing the contents of a folder, creating new folders, changing permissions on files for folders for other users, and combining files, moving things around, and so on. So these are directly to the operating system instead of the Python interpreter. So when you start to do things, sometimes you want to see what's in the file, and you can either open your Finder or you can type in a simple command like ls. All right. So for example, let's take a look at it first. Linux command. So how to do that? So to start to type in a Unix command, so the first thing to do is to type in a BAM sign down here. So BAM ls, ls means list. So if you do that and run this code, and you'll see that you get a list of the file names down there, and you can now see all these files that I have, starting from all these IPYNB files, and there's a folder called datasets where I put all the data points there, or data files there, right? So the first command is ls, means list. So the next one, another useful command to showing the path for your working directory or the current directory is pwd. So pwd, the syntax is bam pwd, so print working directory pwd. So if you do bam pwd, it tells you where your file is. So basically this is telling me that this is an absolute path. So start from users, BZ, Dropbox, teaching, Python for Science, notebooks, and that's where my IPYNB file is, the one I'm using it, right? So if you do, remember that we have relative paths. So I do ls, which is list, and then I do double dot slash. If you still remember that I want to see what's in the folder one layer above, right? So you can see that if you have to do one layer above, and it's right over there. So there are a couple of other folders, and if I want to see the context in the folder students, and you can see that there's, if I do ls double dot slash students up there, and you can see there are two folders. One is all your assignments, and these are all your in class exercise. So these I keep a record on everything you did. Right. So if you try something like this, and you will get a different directory, because these are the things on my computer, and you will get the results based on your own computer. All right. So the third one will be make dir, mkdir, and rmdir, remove dir. So mkdir is making directory. So the syntax goes like make dir directory name, right? So if you take a look at it, I do bam, make dir new folder down here. So by typing this, run it, and I create a new folder called new folder. It's a terrible name, right? So I do ls, and this is my all the folders and files in my current directory. And then now you see a folder called new folder, and that's just made by this command. All right, so the same idea is that you do remove dir, and the same thing. For example, remove dir, new folder, type in here, and this folder is gone, which is quite straightforward. All right. So there are a couple of interesting ones. One is called cat. So cat is the one that lists the contents of a file within Unix commands. Only show a couple of lines of the code, right? So you just what you do is, if I want to see something in the file, I do cat file name. For example, bam cat my functions.py. If you remember, that's a module that we created for ourselves. And you can see that Python, the Jupyter notebook tells you these are all the contents included in this file. All right, so the other one, another one is rm, which is remove file name. So you can tell from the name that if I type in remove my function.py, so this function is deleted. So it's the same thing as you just drag the file and push it in the trash bin. But the thing here is that you can do by command lines. So that's the same idea. So if you're not familiar with how to use this, that doesn't matter, because you can also do delete them by hands. All right, so there are a couple of others. One is called copy, which is CP. So copy one file to another. So if you do CP file name 1, and you'll create another file named as file name 2, but they have the same context, right? So the example here is that if I do CP my funcs.py, and I give a new name called funds.py, and then now I'm creating a new module called funds.py, but it has the same contents as my funcs.py. All right, so that's quite straightforward. So MV is similar to CP, but it's slightly different. So MV basically changes file name 1 to file name 2. So if I do mbfunc.py, so I'm changing this module, funcs.py, to another name called myfuncs1.py. And these are a couple of examples. Right? So these are, you can, of course, you can do things like this just using a rename, type, and Control C, and Command C, Command V, and just drag it to the trash bin to delete it. So these are the command lines that you can do the same thing here, and sometimes they're very convenient. For example, the PWD, I found it very useful because you can know exactly where your working directory is, whether the functions are there or not. So PWD plus ls, that's probably the most useful things that you need to learn. Right. So these are CMD commands from Windows that I can find, because apologize that I'm not very familiar with Windows. And I realized that someone's using Windows and someone's using Linux, Mac systems. So it's probably not fair to ask you guys to try these. But if you're interested in do these command lines and with the file system and directory, and feel free to look through this table and see if you can get some of the commands working in your Python. All right, so next part of the lecture, we're gonna go to one of the most important product of this class. It's called pandas, right? So pandas is very, very useful. So if you know how to use pandas, and then you're halfway through the path of data scientist. All right, so as an overview, so there are huge amounts of data are common in data analysis and data science. So most of data science creates, processes tons of data files every day, and even every hour and every seconds. And then you can use two-dimensional NumPy. We can use two-dimensional NumPy arrays like tables. If you remember that, the earthquake or manku.txt files we used, and also the GDP file and used. And you had trouble that when you load the file, you can either have only string variables or float variables. So NumPy arrays can only take one data type, and this is gonna be annoying, right? So pandas, what is pandas? So pandas is a library, and it's a high-level data manipulation functions, and it can handle more than one data type. So everything created by pandas is called a data frame. It's just similar to everything created by NumPy is a NumPy array, and everything created by pandas is called a data frame. And sometimes you can just regard it's an Excel file, a table, or something like that. So let's take a look at what's there in pandas. If you still remember that we have looked at the function. So now we created the CSV file. There's one CSV file. So still remember this? So cat means I want to see what's that in the file. And then datasets, that's the folder called datasets in my current working directory. So bricks.csv, so that's the file name, right? So you can see if I do cat datasets bricks, and these are the content in the file, right? It's including the country names, population, area, capital, and with 5 countries called BRICS, BRICS in this way, all right? So the bricks file, CSV file, is a 2D table with information of different data types. And if you remember that if you're using NumPy, and you can only choose one data type if you use something like load.txt or gen from txt. So whenever I want one column or another column when they have different data types, I have load in using an option called dtype. And some of you have tried that, right? So that's not very convenient. So now let's take a look at it, what we can do with pandas. So pandas can take care of it, right? So now a couple of things. So we need a library called pandas. So we do import pandas as PD. And you still remember that NumPy as MP and matplotlib.pyplot as PLT. So that's for the plotting. That's for the NumPy arrays. And now I define a file name called file equals to datasets/bricks.csv. So the file name, this is a location, it's a folder where the file is, and that's the file name. All right, so the syntax goes like bricks equals to PD, which is the pandas dot read CSV. So you know that read CSV is a function of the pandas library, and PD is a is the nickname, right? So what I do here is I use a function called read CSV and give you the file name, and also its path plus name. And now I type in bricks. Remember that every line, the last line of a Python code is shown, will be shown on the screen. So if you type bricks, and this is the data results, which is also called a data frame. So this now, by calling the function read CSV, and I'm creating an object or class called data frame. So if we print the type of bricks, and it will be a data frame. And let's show the results, and it's a table, a very nice table, has all the columns with different countries and different data types. Right, so the function name here is read underscore CSV, and the input is file location plus file name, where the file is, right? So if you put the bricks.csv at the same location as your IPYNB file, you don't need the file location. So the output will be a data frame and called bricks in this way. So right, that's very straightforward. So the data frame looks very convenient. You know, it's a very nice way showing what the data is. You can regard this as an Excel table. Right? You have rows and columns. So the problem here is that now the row indices are set numerical as default. And then there's the second column number 2, or column index 1 has a name called unnamed 0, which is very ugly. Right. So it would be much nicer that if we use these these letters as the index for each country. So that'll be much better, right? So that's really easy to fix. So what you need to do is just tell pandas that we want the first column in the data frame to be used as row indices. So instead of just giving a file name, and we turn on one option called index call, which means index column equals 0. So 0 means the first column in the data frame. So if now we print out bricks, now you can see that now these BRRUINCHSA, that's the index. That's the row index. And the country, population, area, capital, that's the column index, right? So now let's take a more detailed look at what the data frame look like and how you can access those data points. And what happens here is that, so the first one, these ones are called column index. So instead, unlike the NumPy, two-dimensional NumPy arrays, and if you still remember that the NumPy arrays column indices are always numerical values, starting from 0 to the end. And the same as row indices, now these row indices are also string variables. Right, so this will be the the shortcut, the names for the countries. So this column index, row index are all string values, means that you can access rows and columns easily just by these names, which will be very readable, right? So remember, if you remember that in the hurricane data, I have to tell you that the first column is latitude, second column is longitude, third column is wind speed, everything blah, and then you have to go type in 1, 2, 3, and that's not very readable. But pandas data frames uses string variables as column index, which is very convenient in this way, right? So how do we access those columns? So there will be the same thing as index slicing through a two-dimensional array. So this is a two-dimensional data frame, right? You have rows and columns. So if I want to have one column, for example, how do I get the first column down here? It's really easy. So if it's a NumPy array and you just do bricks 0, and then your column index is 1, a 0. So that's the first column, right? But for pandas data frame, it's much more straightforward, much more readable, is that I do bricks and country. So that's the index name, the name of the index, right? So if you do that, and it tells you all the names of the country, and then the type is basically an object. So if I do bricks, that's my data frame. I want the column country, So it would just give you a one-dimensional array of all the names of country. For example, you think about if I wanted BRICS.capital, and I got the one-dimensional array of all the capitals, right? So there's another way to do it. So this is the index method. And the other way will be the dot index method. So you would do BRICS dot country rather than putting the string index. So these two methods are equivalent. So you can see that BRICS dot country and give me a one-dimensional array of all the names of the countries. Right? So these two methods are equivalent. You can use either way. And either way, they have different advantages and disadvantages, but they're equivalent. So what about row access? So row access is slightly complicated because if you just take the everything in the square bracket with BR, and it doesn't work that way, because if there's just the square bracket and put an index, it's only for columns. So to get rows, and you need to specify another function called lock, LOC, location. So if you do BRICS.lock BR, and pandas knows that I want the row which has index called BR. Remember that BR is the row index in this way. Now, if you do that, then I get a list of Brazil, country name, population, area, capital, and other property. Right? So that's everything you have. And so when you want to access one of the elements in the data frame, so what you do here is that you can use multiple ways. For example, if I want to get the Brasilia, which is this one, so what I do is I can do first, remember it's the same idea as you access one element from a two-dimensional NumPy array by specifying the indices, right? Here you also specify the indices, but to remember that you need to, for the row, you need to do the lock BR, and the column use capital. Or the order doesn't matter, so you do capital first and lock BR down here, or you just do lock and BR capital and put them all together. So it knows that the results is Brasilia. So if you can see that, the results are the same. So this is element access, and row access, you need a lock, and column access, just put in the country, the row indices as the value in the square bracket. All right, so this is a summary, and to access column, row, and elements, and you need to use slightly different syntax, and this is all you need to know. All right, so the pandas library is also very useful by extending the data frame. For example, if you remember that in two-dimensional arrays, and we mentioned that you can do calculations, you can do index slicing, but if you want to add one row or one column to the two-dimensional NumPy arrays, it's slightly more complicated. You cannot just do simply just to expand or do the append thing. But for pandas data frames, it's really easy. So for example, we have existing data frame, which is the BRICS one, which is this two-dimensional data table. And I want to add one column data called on Earth to tell whether this country is on Earth. Of course they all are. And you can simply just do like BRICS on Earth. So I type in BRICS square brackets, and I give the name of the index called on Earth, and then equals to a list of values. So now the values are Boolean values equals true, true, 5 truths, right? So this is very similar to how you extend a dictionary, if you still remember from lecture 2. So the data type dictionary, you just give a key and the value pair, and then it's extended, right? So if I extend this way and I print out BRICS, and you can see that besides the original data points, and I have one more column here showing this this is a fifth column set with the index called on Earth, and the values are Booleans, and everyone's on Earth, of course. All right. And you can also, using the NumPy array operations, this is also very, very useful to do data analysis with pandas, is that, for example, I want to add one column called population density. right? So the syntax goes the same as bricks, square brackets, and density, which is the column index for population density. So the population density, I want to calculate the population density based on the existing data, which is basically population divided by the area. So I do bricks.population. If you still remember that, bricks.population give me one column where the population is, and divide by bricks.area. So that's the column with all the areas. And this divide, it's the same thing as the element by element operations in NumPy arrays. So what happens here is that at each row, pandas will get the population divided by the area times 1 million, and in this way. So, and then expand it to the last column called density. So if I print it out, and you can see I have one more column called density, which equals to the population divided by the area, and then extend it. So that's very, very straightforward to use. And there are other things that you can try, which is also very useful. And this is also a surviving level command that you need to know, is to change the name of the existing data frame. Because sometimes the names are too long, or they're just not very descriptive, and you need to change it. So the syntax is basically rename. So rename and columns equals to old name and to new name. And there's an option called in place equals to true, and you have to do that. So it means that you do that immediately after you change name. So for example, if you want to change the population to pop and on earth to be cool, and you can see that what I do is I got the name of the data frame, so bricks.rename, and columns equals to populate. I changed the population to pop, on earth to cool, and in place equals true, and you must have that. And I print it out, and you can see now my column index population is changed from population to pop, and then on earth is changed to cool. So, and everyone's a cool country, right? So that's a very handy way to change names. Sometimes when you load a data frame and these indices are way too long or way more complicated, too complicated to type in, so you can change the name of the columns. All right, so we've learned how to load a CSV file, and there's another important skill to learn is to load files using Excel files. Because you've probably seen lots of data files are generated using Excel. So Pandas has very nice function to load files from Excel, and this is even more easier to understand than CSV files, because Excel files looks like a Pandas data frame. Right? For example, if I open the bricks.xlsx file, and you can see that this is basically something looks like a data frame with the row indices and column indices, everything. So to load that file, so the same idea, I'm telling where the file is. So it's in a folder called datasets and bricks.xlsx. And then now the function is slightly different. Instead of PD read CSV, now it's called read Excel, which is very straightforward, right? PD is Pandas. So PD read Excel, where the file is and what's the file name, and index column equals 0 because I want this column to be my index, right? So after you do that and you print out bricks, and you got exactly the same data frame as the CSV file. So that's how you read files from Excel files. So now let's take a look at the Hurricane Mancoot data file. So I created a data file called mancoot.xlsx. And then if you download from Moodle, and then you open the file, which is Excel file, and now you can see it's a very nice file, including all the data points, including the year, month, day, hour, latitude, longitude, and you've already worked with it, and you generate nice plots about the track, and label it bubble plots with colors and different, etc. So it's very cool to do it. So now it's an Excel file, and then we can use the read Excel file to load that, right? So for example, Now let's create a data frame called mancode. So this is a data frame equals to pd.readExcel. So datasets mancode.excelSX, because I put all my data files in a folder called datasets in the same location as the IPYNB file. And then it goes down to this folder to look for that file. And then if I do, here I have a new command called mancode.head parentheses. So the head function displays the first 5 rows of data. And similarly, if you do the tail, it gives you the last 5 rows of data. So both functions are very handy. So the idea that you don't have, if you just type in mancode, it gives you everything. It's way too many data points. But if you just do the head, it only gives you first 5 rows of data, and you can take a look at how your data frame look like, whether is everything all right. So this is how you get the file loaded. All right, so now let's revisit the Hurry mancode data file. If you remember that we generated plots, we had a generate plot that's plotting the relationship between the pressure and the wind. And we also had an explanation why the winds and pressure, wind speed and pressure are related. Right? So how we do that? Remember that when we do the NumPy method, we use the NumPy load file, load the txt, or the other one to load this table into a 2-dimensional array, and we memorized which index corresponds to which data column, and then we extract the data, for example, the wind with the index slicing and the pressure with the index slicing, and then we do plt.plot or plt.scatter, which is the bubble plot, right? So in a pandas data frame, it's much more easier to do. This is that, for example, now remember that we've loaded the data. Now that's my data frame. So I want to plot the pressure as a function of the wind, or the other way around. I want to plot the wind speed as a function of pressure. So what do I do? So if you remember that the scatter function takes 2 1-dimensional arrays. And in the NumPy method, we do index slicing. And in a pandas data frame, you do exact same thing. But index slicing is just typing in the name of the column index, right? So I do plt.scatter mancode pressure HPA. So if you do that, and that code gives me the column with the pressure. And then the second input is mancode wind KT. So that column gives me the wind column, right? So now this code knows that, now Python knows I'm gonna plot wind as a function of pressure in this way, right? Then I label everything and put on a title, and plt.show give me the file. So this is a very straightforward way to do it. And it's the same idea as how we do this index slicing into the NumPy arrays, but pandas gives you an opportunity to do a plot like it in a much more human readable way. And you don't have to memorize which numerical column indices are correspond to these columns. Right. So in this way, you got a horizontal axis, which is pressure, and vertical axis, which is the wind. Right. So that's quite straightforward, and you should try. And in the lecture 9 IPYNB file. All right. So now here's a question. So how do we access this number? Think about it. Right. It's element access, and how we do it. And for the row index, you need to use lock, right? And figure out how to do that. Okay, now let's try some pandas. And this is all for lecture 9.